We're back for quadratic formula round 2. So when we finished with the quadratic formula before, we said sometimes we work a problem out, and this is plugging everything in, and we get this negative sign inside the radical. So up until now, we just stopped and said there's no real solution because I'm not allowed to take a negative, a square root of a negative, in the real number system. So obviously this is a problem because those problems still have to be solved properly, especially in things like engineering and complex applications. So mathematicians created an imaginary number. Just like when you were little and you had an imaginary friend, we have imaginary numbers. There's only one. So the imaginary number is I. So that's a lowercase I, kind of cursive, okay? And I equals the square root of -1. And it was only created to account for those situations when I have a negative sign inside the radical. I squared is equal to -1. So because if I took both sides and squared it, that's what I'd get. So make sure you have these two things written down so you'll know what they look like. Now, how do I use it? When I see something like the square root of -16, first thing you notice is, oh my goodness, I have a negative sign inside the radical. But we're going to split it and treat it as sort of two square roots. It's really the square root of 16 times the square root of 1, right? Because -16 is really 16 times -1. So I do my square root of 16 like always, and I get a 4. But the square root of -1 equals I. So instead of this being 4, it's 4i. When people see that 4i, they know that the original problem had a negative inside the square root, okay? The square root of -25, just take the square root of 25, but the negative sign means I'm going to give it an I, because the square root of -1 is I, okay? So if I came back to this problem, 3 plus or minus the square root of -23 over 8. Now obviously this is a messy number. It doesn't simplify. It's not going to be a nice rational number. It's going to be a never-ending decimal, so we put it in this form. But take a look at how I would write it in its finished form. I would simply take that negative sign and bring it out, and I would have 3 plus or minus I radical 23 over 8. Now, as before, if anything was able to be simplified, we would do that, like with all fractions. Like, for instance, if these were all even numbers. But they're not, so this is my final answer, and it's good. Okay? Always remember to do the plus or minus with these. Let's look at another one. X squared plus 13 equals 6x. Well, the first thing I notice is it's not in standard form. So I subtract over the 6x, and now I'm in standard form, and I'm ready to apply my numbers. Negative b plus or minus the square root of b squared minus 4 times a times c. And I'll tell you a little secret about this. When there's a negative, I put it in there to show you, but I never actually use the negative in my calculator when I'm squaring it, because what is -6 times -6? It's always going to be positive if I'm squaring it. It's the same as +6 times +6. And sometimes students put things in the calculator incorrectly and they end up with the wrong answer. So it's actually easier, don't even worry. Now out here I do have to worry about it, but if I'm squaring it, negative times negative equals positive, so the negative sign doesn't matter when I'm squaring it. So I get 36 minus 52, and in fact I get a negative inside here. So I have 6 plus or minus the square root of -16. So I know that that's going to be 4 and an I. So 6 plus or minus 4i divided by 2. Now here's a scenario. Do you notice about every single one of these coefficients? Every one of them has divisible by 2. So I divide them all by 2 and I get 3 plus or minus 2i. Okay? So we're using the quadratic formula exactly the same. But when we get down here with that negative sign, we're doing this one extra step. As always, you should be pausing and writing down as many examples as you need so that you can do this yourself. Now I want to remind you, before we've talked about that the real solutions are where it crosses the x-axis. But what about those cases when it didn't cross the x-axis? Again, when you see the i's in the solution, that means it looks like this. Or it might be upside down here, but it's never crossing the x-axis. That's what these scenarios are. So x squared minus 4x plus 5, I put it in the quadratic formula. I get 4 plus or minus 16 minus 20. I can see right there it's going to be negative because 16 minus 20 is a negative number. And I get 4 plus or minus the square root of -4 over 2. The square root of 4 is 2. The square root of negative is I. So I have 4 plus or minus 2I divided by 2. And one more time, I see that these are all 3 divisible by 2, so I divide out the 2, and I get 2 plus or minus I. Okay? That means whatever the solutions are to this equation, it's imaginary, so it's not something we're actually going to physically graph, but we'll know that that number would be 2 plus or minus I. Now, I want to remind you that this plus or minus is important. It means there are actually 2 solutions, 2 plus I and 2 minus I. Those are both solutions. Complex numbers is another word for part real, part imaginary. So I have a real number here and an imaginary number here. So 2 plus I is a complex number. It mixes the real and it mixes the imaginary. Okay? I is imaginary. But anytime I'm having it multiplied or added to something else, it becomes a complex number. Make sure you know that vocabulary. And they always travel in pairs. Okay? They're called conjugate pairs. Conjugate pairs. Conjugate means they go together. Okay? They're married. Here's other examples of conjugate pairs. X plus 3, x minus 3 are conjugate pairs. X plus square root of 7, x minus square root of 7. X plus 3i, x minus 3i. Do you see the pattern? Conjugate pairs, and we'll multiply those in class, will always, because of this plus minus pattern, will cancel out that part in the middle, the ugly part, the part that would have i's, and we'll only have to worry about the parts on the end. So we'll start multiplying these next time, but I just want you to know that they always travel in pairs. You can't ever have just 2 plus I. If you have 2 plus I know you also have 2 minus I, because they must go together in conjugate pairs. Okay? All right. That is the end of today's lesson, so we'll work on this.